Hello students, welcome back to day 19 of 99% in 99 days in your class 10th board. So today we have already done the chapter acids, bases and salts, and today we are going to solve the most expected questions from acids, bases and salts. Okay, so if you practice these questions, then definitely you will be able to crack the questions in your board examination. So let us start first. What will you get in this lecture? So we will be covering around 20 MCQs, okay, and there will be one assertion reason questions, there will be two marker questions, there will be three marker questions, 21 3 marker questions, we'll have 3 5 marker questions, and we will also have case based questions. Okay, so you can see a wide range of questions will be covered, so please practice with me so that you can score really good in your board examinations. Coming to the first question here. Which of the following oxides is or are soluble in water to form alkalis? Okay, so now if you want to see what is alkali is those bases which are soluble in water. Okay, now the question is asking which of the following oxides is or are soluble in water to form alkalis. Okay, so now generally what happens, you can find that you need to find, so you can find that metallic oxides, metallic oxides are generally soluble in water, and they form bases. Metallic oxides will form bases, right? So you can see these two are metallic oxides, these two are non-metallic oxides. So if you dissolve this in water, they will form acid. If you dissolve these in water, they will form base, right? So, or you can say alkalis. So option number A is the correct answer. Next we have you can see this setup here. Study the diagram given below and identify the gas formed in the reaction. So you can see pop sound. So pop sound is with hydrogen. So correct answer is option number D here. Next, which of the options in the given table are correct? So you can see orange, oxalic acid, sour milk, lactic acid. This is correct. Ant string, methanoic acid, tamarind, acetic acid. So you can see 2 and 3 are correct. So option number C is the correct answer here. Next, you have to select from the following the statement which is true for bases. So bases are bitter and turn blue litmus red. No, this part is wrong. They turn red litmus blue. So this is wrong. Next, bases have a pH value less than 7. No, they have greater than 7. Bases are sour. No, they are bitter. Bases turn pink when a drop of phenolphthalein is added to them. Yes, correct. That is option number D. Next, coming to question number 5. Here there is parent acid, parent base. So you have to tell which of them is the correct option. So in sodium chloride you have NaOH and HCl, and the salt should be basic. No, because it is a strong acid and strong base. So what should be the answer here? This salt should be neutral salt. Now if you have sodium carbonate, so parent acid, and this is correct, and this is neutral. No, because it is a strong base, so this one should be a basic salt. Now sodium sulfate, H2SO4 and NaOH both are strong, so again this should be neutral. This is also wrong. Sodium acetate, you have NaOH and CH3OH. Now because it is a strong base, so it will be basic. The correct answer is option number D here. Next, we'll go for question number 6. Consider the pH value of the following acidic samples, the decreasing order of their H plus concentration. So lower is the pH value. Here you should know lower pH value means high H plus concentration. So now if you see gastric juice is having the least pH value of 1.2. So its hydrogen ion concentration will be maximum. So 2 will be maximum, so we can eliminate these two options. After that we have 1 out of 4 and 3. So now you see 3 is having less pH value, so it will have more hydrogen ion concentration. So after 2, 1, there will be 4 and then 3. So option number C is the correct answer here. Next, you have study the experimental setup shown in given figure and choose the correct option from the following. So here, Now if you see K2CO3 is there, Cl2 gas is there, no change is there. Okay, change observed in calcium hydroxide. So you are taking this gas and putting in calcium hydroxide solution. Carbon dioxide gas, no change, no. H2 gas turns milky, no. Carbon dioxide gas turns milky, that is correct. So option number D is the correct answer. Okay. Next we have, when a small amount of acid is added to water, the phenomena which occurs are, okay, you have added small amount of acid to water. Okay, one second. So that is called as dilution. Obviously this is not neutralization. Formation of H3O plus, that is also correct. So 1 and 3, that is option number A. Next question number 9, in an aqueous solution A, okay, phenolphthalein solution color is pink. You have aqueous solution A, okay, and then if you add phenolphthalein, its color is changing to pink. This concludes that A is a base. Okay, so A is strongly, okay, let us read the next part. On addition of an aqueous solution of B, okay, once then you added B to this one, B to A, the pink color disappears. So pink color disappears on addition of B. Which of the following statement is true for solution A and B? So we know that A is a base, so we can eliminate this option. A has pH greater than 7, that can be correct. A has pH less than 7, that is also incorrect. Now A is strongly basic and B is a weak base. No. Now see, when it is becoming colorless, that means there is neutralization reaction happening. Okay, so B is a strong acid. So when acid and base are reacting, it is neutralizing, so that is why the pink color is disappearing. So that is why A has a pH greater than 7 and B has a pH less than 7. So correct answer here is option number C. Next, coming to question number 10, which of the following salts do not have the water of crystallization? Bleaching powder, you know the formula, it doesn't have CaOCl2. Okay. Next, if you see plaster of Paris formula is CaSO4 dot half H2O. Okay. Next, in washing soda, it is Na2CO3 dot 10 H2O. Okay. Baking soda is NaHCO3. So there is water, do not contain water of crystallization is your bleaching powder and baking soda, right? 1 and 4. So we have option number D here. Okay. Next is question number 11. Baking soda is a mixture of sodium hydrogen carbonate and tartaric acid. Okay, option number, yes, correct, sodium hydrogen carbonate and tartaric acid. Next, question number 12. The chemical formula of plaster of Paris, that is calcium sulfate hemihydrate dot half H2O. Next, acid present in tomato is oxalic acid, right? Lactic acid is present in milk, acetic acid is present in lemon, methanoic acid is present in ant strings. Next, sodium hydroxide is termed an alkali, whereas ferric hydroxide is not. Okay, what is the reason? So alkali means it should be soluble in water. Okay, so sodium hydroxide is a strong base while ferric hydroxide is a weak base. No, sodium hydroxide is a base which is soluble in water, while ferric hydroxide is also a base but it is not soluble in water. Yes, option number B is the correct answer here. Next, the name of the salt used to remove permanent hardness from the water, that is your washing soda, or you can say sodium carbonate dot 10 H2O. Okay, so we have sodium carbonate decahydrate, that is your washing soda. Okay. Next, question number 16. When sodium bicarbonate reacts with dilute HCl, the gas evolved is. Okay. When sodium bicarbonate reacts with dilute HCl, the gas evolved is your hydrogen, right? So we have hydrogen here, also hydrogen, carbon dioxide not required. It gives a pop sound with the burning matchstick. Correct answer is option number A here. Oh, sorry, one second. Okay, one second. Sodium bicarbonate is reacting with HCl. So if I write the reaction here, I'm very sorry, I didn't see it is sodium bicarbonate. So if you have sodium bicarbonate, right, NaHCO3, okay, and it is reacting with an acid. So you will get here, first you will get salt NaCl plus CO2 plus H2. Okay. Now here what happens, you are getting CO2 gas, okay, CO2 gas, and it turns lime water milky. Option number C is the correct answer here. Next, few drops of aqueous solution of ammonium chloride are put on a universal indicator paper, okay, ammonium chloride, okay. Now the paper turns pink, okay. Study the following table and choose the correct option, okay. So NH4Cl is made up of what? NH4OH, okay, and HCl, okay. So it is a weak base and strong acid, right? So where we will get that option? Weak base, yes, weak base and strong acid. So definitely the salt is acidic and the pH will be less than 7. Option number C is the correct answer here. Next, two salts X and Y are dissolved in water separately, okay. When phenolphthalein is added in these two solutions, the solution X turns pink. Solution X turns pink. That means what? X must be a base, right? And the solution Y does not show any change. So Y has no change, right? That means what? Y must be acid, okay. Therefore X and Y are, so X is any base, so you can see, okay, or you can say can be base or basic salt, okay. So basic salt means you should have a strong base and weak acid. So basic salt, we can see that, okay. Now in X, yeah, this can be a basic salt, this will be a neutral salt, right? This is a neutral salt, this is acidic salt, and this is also neutral. So option number A has to be the correct answer. And if you see here Y, this is acidic because it is weak base and strong acid, okay. Next, question number 19, a solution turns the color of turmeric to reddish brown if the same solution is poured on universal indicator, its color would change too. Now if you remember turmeric, okay, turmeric changes to red color in the basic medium, right? That means this solution, okay, solution turns red, this solution turns the color of the turmeric to reddish brown. So this solution must be a basic one, and in the pH paper for base the color is blue, okay. So the correct answer here will be option number B. Next question, the correct statement about these equations is, okay, pH are given, which solution would liberate hydrogen gas with zinc? So with zinc, if you want hydrogen gas, it should be either acid should react or base should be reacting, right? So you can see A will definitely react because it is a very strong acid, and D will also react because it is a very strong base. These are somewhere between the neutral point. So A and D, that is option number C here. Next, we'll do one assertion question. NaHCO3 is used as an ingredient in antacids, that is correct. NaHCO3 is a mild corrosive base salt, okay. Yes, that is why it is used, because it can neutralize the excess of acid and it is mild, so that is why it is not even harmful to your body. So both assertion and reason is correct, and reason is the explanation of the assertion. Next, coming to 2 marker questions here, okay. A teacher provided acetic acid, water, lemon juice, aqueous solution of sodium hydrogen carbonate and sodium hydroxide to a students. Okay, let us write down what are these things. Acetic acid is there, okay, I am writing the formula of acetic acid. Then you have water, okay, then you have lemon juice, okay, then you have sodium hydrogen carbonate. Next we have sodium hydroxide, okay, and one of the student reported the pH values of the given substances as 3, 12, 4, 8 and 14, okay. So now if you see this, we can say because it is a base, this is correct. Lemon juice is an acid, it is correct. This is also acid, this is also correct. But water, if you see the water pH is 7, it is neutral, right? So that is, question is which one of these value is not correct? Write its correct value stating the reason, okay. So the pH of water is given incorrect, the correct value will be 7, okay. Next question, What is observed when 2 ml of dilute HCl is added to 1 gram of sodium carbonate? Taken in a clean and dry test tube, write the chemical equation for the reaction involved. So you have acid and carbonate, so definitely carbon dioxide gas will be produced, and what will you observe in this case? You will observe effervescence, okay, and the reaction Na2CO3 plus HCl will give you salt, carbon dioxide and water, okay. Next, okay, here students, I want to introduce you to something called as DSAT. Now you are in 10th standard, right? So now definitely the next 2 years are going to be very crucial. You need to choose the proper stream for you, and to help you with this, Diksha has come up with a very good solution, that is Diksha Scholastic Aptitude Test. So here what happens is you get a 60-minute lecture, then you attempt an aptitude test. This test is evaluated by very good experts, and then they mentor you one-on-one and then tell you your weakness and strength and guide you which career is the best choice for you, okay. So if you want to make use of this, then please you can go to the description section of this video, register for DSAT, and then please take the advantage of this help that is offered to you. Okay, next question will be now going to 3 marker questions. We have 20 questions almost, so let us solve them quickly. A student took a small amount of copper oxide in a conical flask and added dilute hydrochloric acid to it with constant stirring. He observed the change in color of the solution. Write the name of the compound formed and its color. So copper oxide plus HCl will give you copper chloride, okay, and the color is blue-green. Okay, write the balance equation for the reaction. CO plus HCl will give you CuCl2 plus H2O, and then to balance it you can write down 2HCl. Okay, yeah. Next question number 2. The industrial process used for the manufacture of caustic soda. So caustic soda is nothing but NaOH. Okay, involves electrolysis of an aqueous solution of compound X. In this process, 2 gases Y and Z are liberated. Y is liberated at cathode, Z is liberated at anode. On treatment with dry slaked lime forms a compound B. Name X, Y, Z and B. So if you guess this one, X obviously is your brine solution or NaCl solution, and Y is liberated at cathode, so Y has to be H2. Z is liberated at anode, so Z will be Cl2. Next, which is liberated at anode on treatment with dry slaked lime. So now when you treat this one, dry slaked lime, okay, plus Cl2, okay, this one will be CaOCl2, okay, and this is nothing but your bleaching powder, okay. So name X, Y, Z and B, okay. Next question number 3, suggest a safe procedure of diluting a strong concentrated acid. So that is, name the salt formed when sulfuric acid is added to sodium hydroxide and write its pH. Dry HCl gas does not change the color of the dry blue litmus paper. Why? Okay. So very simple answer. What is the correct way? You should add acid to water. Now what is the salt formed here? Because it is a strong acid and a strong base, you will get Na2SO4, and because it is a neutral salt, the pH value will be 7. Okay. Next, dry HCl does not change the color because in dry HCl does not have H plus ions. Okay. For color change we need H plus and OH minus ions, but in dry HCl there is no H plus ion, so that is why it will not change the color. If you take a wet litmus paper here, then HCl will react with the water present there and will produce H plus, and as a result of which you can see color change. Okay. Next, why is acidified water considered to be a good conductor of electricity? So that is, okay, let us see all the questions here. Write a chemical equation showing the ionic products formed on dissolving potassium hydroxide in water. Care must be taken while diluting the concentrated nitric acid with water. Why? Okay. So here first of all, why acidified water is considered as a good electrolyte? Because it has free ions, it can conduct electricity. Next, write a chemical equation to show the ionic product. Potassium hydroxide when dissolved in water will get K plus and OH minus. Next, very important question, why you should always add acid to water? So this dissolving or diluting or adding acid to water is an exothermic process. Heat is released in that process, right? So being an exothermic reaction, a large amount of heat is generated. While diluting concentrated HNO3, this heat may cause the mixture formed to splash out and can cause severe burns. Okay, so that is why it is always advisable to add acid to water. Okay, so make sure, because it is an exothermic process, if you do the reversed, all amount the heat that is released, okay, that can lead to explosion. But if you add acid to water, the heat that is released will be absorbed by water, okay, because water has high specific heat capacity. Okay, next is question number 5 here. Consider the following statements: YCl, NH4X and ZCO3. Okay, what would be the pH of the salt solution in YCl? Y is sodium. Okay, so if Y is sodium, then it is NaCl, salt is NaCl, strong acid, strong base. So what will be the pH? The pH will be 7, right, because it is a strong acid and strong base. So pH will be 7. Why? Because it is a salt of strong acid plus strong base, or I can say this gives to neutral salt. Okay, next you have, if in the salt NH4X, X is a nitrate group. Okay, so that means what is the salt we are getting? NH4NO3. Okay, so that means this is a weak base, this is a strong acid, so definitely the salt is acidic. Okay, fine. Then its solution will give what color with the universal indicator? So if it is an acidic salt with indicator, okay, it will give you red color, right? Next, why? Because it is an acidic salt. Now what would be the change in the color in blue litmus solution if ZCO3 is added to it and Z is potassium? So KCO3 is there, right? So that is what, this is a basic salt, right? Why? Because here you have KOH and you have H2CO3. This is strong base and this is weak acid, right? You will get a basic salt. Now once you are getting basic salt, so in basic salt what happens? Red changes to blue, but if you put it in blue, then there will be no change here, so no color change will be observed in this case. Okay, if it would have been added to red litmus, then it would have changes to blue. Okay, one second, blue changes to red in acidic, right? Yeah, so that is why there is no change here. Next, question number 6. What property do acids and bases have in common? Explain it with an example. A compound which is prepared from gypsum has the property of hardening when mixed with water. Identify the compound and write its formula. How is this compound prepared? Describe it in the form of a chemical equation only. Okay, first part, let us see what is common in them. So the common is they are good conductors of electricity. They produce ions on dissolving in water. Acid gives H plus and bases give OH minus. Okay, then what is there? You have to write, give an example. So that is the example that you have given, that they have giving different types of ions. A compound which is prepared from gypsum has the property of hardening when mixed with water. Identify the compound. It is plaster of Paris. Chemical formula is calcium sulfate dot half H2O. Right. Next, identify the compound and write its formula. How is this prepared? Describe only equation. So it is prepared if you take gypsum. Okay, so I'll write here like this: CaSO4 dot 2H2O, and if you heat it, you get CaSO4 dot half H2O. Sorry, half H2O plus 1 by 2 H2O. Okay. Next is question number 7. Write the chemical name and molecular formula of tooth enamel. Okay, this is there in your book. How does it get corroded? What is the preventive measure for this? So the chemical name for this one is calcium hydroxyapatite. Formula is Ca10PO4(6OH)(2). Formula is not given in NCERT, so make sure that you note this down. Okay. Next, how does it get corroded? So if pH falls below 5.5, the enamel gets corroded. What is the preventive measure? Toothpaste are basic in nature and neutralize the excess acid. Prevent and prevent the tooth decay. So you should brush your teeth regularly. Okay. Next, coming to question number 8, a substance X is used as a building material and is insoluble in water. Okay, fine. So when it reacts with dilute HCl, it produces a gas which terms line water milky. What is the chemical what is the chemical name and the molecular formula of X? So I hope all of you gained, because it is insoluble in water and it is a building material. So definitely X is nothing but calcium carbonate. Okay, write its chemical name and the formula is written. Chemical name is calcium carbonate. Right. Next we have part B, that is write the chemical equation for the chemical reactions involved in the stone statement. So that is the reaction of calcium carbonate with HCl. Okay, that will give you CaCl2 plus CO2 plus H2O. Okay, so now you have 2 HCl here, calcium, calcium, carbon, carbon, oxygen 3 is there, 2H and 2Cl, that is balanced. Okay. Next question number 9, a metal M on reacting with dilute acid liberates a gas G. Okay, so metal on reacting with dilute HCl liberates gas G. Okay, fine. The same metal also liberates gas G when reacts with a base. Same metal when reacting with a base, okay, is also giving you the same gas G. Okay, write the name of the gas G. So that is your hydrogen gas. All of you would have guessed by now. Now how will you test the presence of this gas? By matchstick, right? If you bring a matchstick too near it, it burns with a pop sound. Okay. Next, write the chemical equations for the reaction. So if I want to write some chemical equations here, so that will be, we can write the example of, for example, Zn. Okay, metal reacting it with HCl will give you ZnCl2 plus H2. Balance it, you can write 2HCl. This is with acid. Okay. Next is with base. Now if with base it is there, Zn plus NaOH will give you Na2ZnO2 plus H2O. Okay, so now you can make it 2Na, Zn is there, 2 oxygen, and we have 2 oxygen, so not H2O, it is H2. Okay, so 2 oxygen, 2 oxygen, 2 hydrogen, 2 hydrogen, so that is also correct here, right? Next, question number 10, complete and balance the following chemical equations. So NaOH plus zinc, okay, so that will give you salt plus water. Just now we wrote here, 1 second. Okay, so we have NaOH, right, plus Zn. So this will give you sodium zincate, Na2ZnO2 plus H2. Right. So now to balance this, I'll just make 2Na. So 2Na, 2Na, 2 oxygen, 2 oxygen, 2 hydrogen, 2 hydrogen, and zinc 1 is there. Next you have calcium carbonate, okay, plus, this reaction is important, okay, plus H2O plus CO2. Okay, this one will give you product of calcium bicarbonate. Okay, let us see whether it is balanced or not. You have one carbon, calcium. Here we have two carbons, then we have two hydrogens, and then we have 3, 2, 5, 6 oxygen, and here also 6 oxygen. Yes, this is also balanced. Next, HCl plus H2O. You have HCl plus H2O will give you H3O plus Cl minus. Okay, so that is 2 and this is 3. Next, question number 11, how is washing soda prepared from sodium carbonate? Give its chemical equation, state the type of this salt, name the type of hardness of water that can be used to removed by it. Okay, so let us do this question. How is washing soda prepared from sodium carbonate? Give its chemical equation. So first, if I want to write how it is prepared, so you can write down sodium carbonate, okay, gives washing soda on crystallization. Okay, next give its equation. So to write the equation, you can write Na2CO3 plus 10 water, okay, gives you Na2CO3 dot 10 water. Okay, next state the type of this salt. So you can write down this salt is made up of strong base and weak acid, right? So it is made up of okay, it is just asked to mention the type, so we will write. Okay, I'll tell you for this one. Now see, this Na2CO3, okay, is made up of NaOH plus H2CO3. This is strong base and this is weak acid. Okay, so now if strong base is there, then the salt will be basic in nature, so that is why this is basic in nature. Next, name the type of hardness of water it can remove. That is, it can remove permanent hardness. Okay, fine. Question number 12 here. During the electrolysis of brine, a gas G is liberated at anode. Okay, so let us note down this one. So at anode, you have been with gas G. When this gas G is passed through Schleck line, so when you pass it through Schleck line, that is calcium hydroxide, okay, a compound C is formed, okay, which is used for disinfecting drinking water. What is the formula of G and C? So you must be knowing now, G must be chlorine, okay, only formula is asked, and C is your bleaching powder, that is CaOCl2. Next question B is state the chemical equation involved. So chemical equation involved here, you can write down CaOH whole 2 plus Cl2 gives you CaOCl2. Okay, now whether CaOCl2 plus water, right? So now if you see carbon is there, 2 hydrogen, 2 chlorine and then 2 oxygen. It is already balanced. Next, what is the common name of the compound C? The common name of the compound C is bleaching powder, right? And what is its chemical name? Chemical name is calcium oxychloride. Okay, fine. Let us see the next question here. Okay, identify the acid and base from which sodium chloride is obtained. Very simple question. So in sodium chloride, the acid is HCl and base is NaOH. Okay, next, which type of salt it is? Because it is made up of a strong acid and strong base, it is a neutral salt. Okay, next, when is it called rock salt? So this answer you can see. Now when this salt is, wait a second, this one I'll write here, the second part that it is a neutral salt. Okay, now when is it called a rock salt? So now see, large brown crystals of NaCl combined with impurities is called as rock salt. Okay, now how it is obtained? It is obtained from the drying up of seas. When large sea dry up, the brown crystals are formed and these are called as rock salt, and these are brown because of impurities. Okay, next, question number 14. Okay, identify the acid and base which form sodium hydrogen carbonate. Okay, so for sodium hydrogen carbonate, okay, so for sodium hydrogen carbonate, okay, so acid present here is your carbonic acid, that is H2CO3, okay, and base present is sodium hydroxide. Done this part, clear? Next, write the chemical equation in support of your answer. Okay, so you can write down chemical reaction means how this salt is formed. So we can write like this: NaOH, okay, plus H2CO3 gives NaHCO3 plus H2O. Okay, Now for balancing, you can see sodium, 1 sodium, then we have 3 hydrogens, so we have 3 hydrogens, oxygen we have 4, oxygen here also 4, then you have 1 carbon and 1 carbon, right? This is also done. Now state whether this compound is acidic, basic or neutral. So if you see here, right, it is a strong base and weak acid, so definitely it will be a basic salt. Okay. Next, the question is asking write its pH value. Basic salt means the pH will be greater than 7. Okay, you do not have to write the exact value, you need to write above 7 or below 7. Okay. Next, question number 15. While diluting an acid, why is it recommended that the acid should be added to water and not water to the acid? Dry hydrogen chloride gases does not change the color of the dry litmus paper. Why? Okay, here you can see the answer I have written in detail. So diluting an acid is an exothermic process, means when you dilute it, heat is released. Okay. Now when water is added to an acid, the heat generated may cause the mixture to splash out and can cause severe burns. Okay. Therefore, it is recommended that acid should be added to the water carefully with constant stirring. So in this, when you are adding acid to water, the heat release will be absorbed by water. Okay. Next is question number B, that is presence of ions like H plus and OH or H3O plus changes the color of the litmus paper. Now dry HCl is able to produce these ions only in the form of aqueous solution. Now hence dry HCl is gas does not change the color of dry litmus because there is no ion in dry HCl. Okay. Question number 16, how is sodium hydroxide manufactured in industries? Name the process. Okay. So how it is manufactured? It is manufactured when electricity is passed through brine solution, means NaCl solution. If electricity is passed, you will get sodium hydroxide. And next question is what? Name the process. So this process is called as, if you remember, what is the name of this process? This is called as chlor-alkali process. Okay. Yeah, this is called as chlor-alkali process. Next we have, in this process a gas X is formed as a byproduct. This gas reacts with lime water to give a compound Y, which is used as a bleaching agent in the chemical industry. Identify X and Y and also write the chemical equation of the reactions involved. So gas which is here is what? X is your chlorine gas, okay, and Y is it is reacting with lime water to give you compound Y, that is your bleaching powder, CaOCl2. Okay, now you have to write this reaction. So reaction is like this: calcium hydroxide plus Cl2 gives you CaOCl2 plus H2O. Okay, so now if you see, we have calcium, oxygen 2, 2 hydrogen and 2 chlorine. It is balanced reaction. Clear? Next, question number 17. On heating blue colored powder of copper nitrate in a boiling tube, black copper oxide is formed. O2 and a brown gas is liberated. Identify the type of the reaction and the gas. Okay. So this is your, the type of reaction is nothing but thermal decomposition. Okay. Thermal decomposition. Now identify the type of the reaction and gas X, because it is a brown gas, so gas X is nothing but NO2 gas. Okay. Next, question number B, write the balanced chemical equation for the reaction. So you have to write the decomposition reaction of copper nitrate. Okay, so this is copper nitrate. 1 second. See, copper nitrate is there. So it will decompose to give you copper oxide plus NO2, okay, and they have told you oxygen gas is produced. Okay. Now if I want to balance this one, so I can write it like we have 1 copper, 6 oxygens are there, okay, 2 nitrogens are needed. So if I make it 2 like this, so we get here copper nitrate, NO3 minus copper nitrate, yes, that formula is correct. So now copper, we got copper here, oxygen is 6, so here we got 2, 2, 4, 5, 6, 7 oxygen we are getting. And then nitrogen is balanced. 1 second. Copper nitrate gives you copper oxide. Copper oxide formula, black color copper oxide. Now let us see the question number B here. Write the balanced chemical equation for the reaction. So if you want to write the balanced chemical equation, so we have copper nitrate, okay, and it decomposes to give you copper oxide, okay, plus NO2 and plus O2, okay. Now if I want to see, there is 2 nitrogen, so I'll make it 2 nitrogen, okay. Now if I see in this way, oxygen is not balanced now, right? 4, 7 oxygen, and here we have 6 oxygen. So what I'll make is, I'll make this one also 2, okay. Now if this one is 2, then we have total, we have how many nitrogens? If you see, 4 nitrogen, right? So I have to change this to 4 NO2, and this one 2 copper, so I'll make it 2 copper. So now if we see 2 copper, okay, then I have 4N, so 4N is there. Oxygen, I should say 6, 12 oxygen, 4 to the 8, 9, 10, 11, 12. That is also balanced, okay. Write the pH range of the aqueous solution of the gas, okay. So NO2, okay, this when you dissolve it in water, it forms nitric acid, right? So acid will form, so the pH range will be less than 7, okay. Next question number 18, what is brine? What happens when an electric current is passed through it? Write the chemical equation for it, okay. So what is brine? So first of all, we will write what is brine. The first part of the question, brine is what? Brine is aqueous NaCl solution, okay. Now what happens when an electric current is passed through it? So when electric current is passed through it, it decomposes to form NaOH, Cl2 is produced at anode, and H2 is produced at cathode. Next, write the chemical equation for this one. Sorry, so chemical equation we need to write. So NaCl, okay, plus water will give you NaOH, right, plus H2 and plus Cl2, okay. So now you can see here we have H2 and Cl2, so I'll make it like this, okay, and I'll make this one. So now I am having we have 2 oxygen, so I will make this one also 2, right. So 2 Na, 2 Na, 2 Cl, 2 Cl, 4 hydrogen, then we have 4 hydrogen, 2 oxygen, 2 oxygen, okay. Next is question number 19. Now we are moving, we are discussing 3 marker questions till now, okay. 2 ml of NaOH solution is added to few pieces of granulated zinc metal taken in a tube. When the contents are warmed, a gas evolved which is bubbled through a soap solution before testing. Write the equation of the chemical reaction, the involved, and the test to detect the gas. Name gas which will be evolved when the same metal reacts with dilute solution of a strong acid, okay. So here the question is, we have zinc with NaOH, okay. The first question here is, write the equation of the chemical reaction taking place. So equation is what? Zn plus NaOH, okay, will give you Na2ZnO2, okay, plus H2, clear. Next, write the equation of the chemical reaction involved and the test to detect the gas. So gas is hydrogen, so what is the test here? Pop matchstick, okay, matchstick will give you a pop sound, okay. I am not writing the full sentence, you can write down, when a matchstick is burnt near this hydrogen gas, it burns with a pop sound. Name the gas which will be evolved when the same metal reacts with dilute solution of strong acid. Strong base, right? Strong acid. So again, if the metal reacts with strong acid also, we will get the reaction like this, okay. ZnCl2 plus H2. So the gas that is produced here is also hydrogen gas. Clear? Next question number 20. For the preparation of cake, baking powder is used. If at home your mother uses baking soda instead of baking powder, how will it affect the taste of the cake and why? Next, how is baking soda be converted into baking powder? Next, what makes the cake soft and spongy? Okay, so very easy question this one. So first of all, the cake will have a bitter taste because of the formation of sodium carbonate. When you are taking baking soda, baking powder, right? Baking soda is NaHCO3. Okay, when you are cooking it, when it get heat, it decomposes to give you Na2CO3, right? And this can make the taste bitter. Okay. Next is, how is baking soda be converted to baking powder? By adding tartaric acid to it. Next, what makes the cake soft and spongy? The liberated CO2 gas. Okay. Next, question number 21. The pH of a salt used to make tasty and crispy pakoda is 14. Okay. Identify the salt and write a chemical equation for its formation. Okay. List 2 uses. Okay. So here, if you can remember, this is your baking powder. So that is NaHCO3, or you can say baking soda. Baking soda is used in pakoda and all. So NaHCO3. Next, you have to write a chemical reaction for its formation. So this one is formed from NaCl with H2O, CO2 and NH3 to give you NH4Cl and NaHCO3. What are its other uses? It can be used as, it is used in baking powder, it can be used as an antacid, it can be even used as a fire extinguisher. Okay. Next, we'll go to now 5-marker questions. Write the main difference between an acid and a base. With the help of a suitable example, explain the term neutralization and the formation of acidic, basic and neutral salts. Okay. So first of all, what is the main difference of acid and base? So you can write down acid and base. We can write 3 points of difference, or I can write 2 points of difference. First is, it produces H plus, it produces OH minus. Second is, it is, I can say, sour in taste, this is bitter in taste. Okay. Next, we can say about litmus, it turns blue litmus to red and this turns red litmus to blue. Okay. With the help of suitable examples, explain the term neutralization. So what is neutralization? Neutralization, right, is the reaction between acid plus base. You can give an example like NaOH plus HCl. Okay, this is a base, this is acid, will be NaCl plus water. Okay. Next question is asking formation of acidic salt. So if you want to write acidic salt, you should take strong acid and weak base, right? Strong acid, I can say HCl, and weak base is like NH4OH, and these two will combine to give you NH4Cl plus H2O. Okay. Next, if we have basic salt here, okay, yeah. So for basic salt, we need a strong base, right? So if I take NaOH and a weak acid, CH3COOH, and this one will give you CH3COONA plus H2O. Okay. Next, coming to the third one, that is acidic, basic, then neutral salt, right? So for neutral salt, you can take the example of a strong acid and a strong base. Okay. So NaOH plus HCl will give you NaCl plus water. Okay, that is there. Next, coming to question number 2, 4 samples A, B, C and D change the color of the pH paper or solution to green, reddish, pink, blue and orange. Their pH was recorded respectively. Which of the following samples has the highest amount of hydrogen ion concentration? So we have like this A, B, C and D, and their pH values are 7, 2, 10.5 and 6. Okay, fine. Hydrogen ion concentration is maximum if the pH is low, right? So that is which solution? That is solution B. Okay. Arrange the 4 samples in the decreasing order of their pH. So that will be C, A, then D and then B. Okay. Next, Rahul found that the plaster of Paris which he stored in a container has become very hard and lost its binding nature. What is the reason for this? So what is the reason here? When you leave calcium sulfate hemihydrate, it absorbs moisture and it get converted to gypsum, right? So that is why it loses its binding activity. Now write the chemical equation to represent the reaction taking place. So the chemical reaction is like this: dot half H2O plus we have 1 and half H2O to give you calcium sulfate dot 2H2O. Okay. Next, give any one use of plaster of Paris other than plastering or smoothing of walls. So you can write down here for making decorative items. Okay. Next, question number 3. State the chemical properties on which the following uses of baking soda are based. It is used as an antacid. Why? Because of its mild, non-corrosive basic nature. Okay. Next, it is used as a soda acid fire extinguisher. Why? Because it produces CO2 on decomposition. Okay. To make bread and cake soft and spongy, that is because it produces, again, that is CO2 with tartaric acid. Okay. Next, how is washing soda obtained from baking soda? So baking soda is NaHCO3. Okay. So if you heat it, we get Na2CO3, okay, plus CO2 plus H2O. Okay. Then when you give this one with 10 molecules of water, we get Na2CO3 dot 10 H2O, which is nothing but washing soda. Okay. And you have to write the chemical equation. Clear? Next, we'll go to a case based question here. This is very interesting question. See, a pH paper changes its color, okay, depending on the pH value of the substance it is dipped in. The picture shows the different colors of a pH paper. Lina tested the pH value of 4 liquids using the pH paper. The table is there. Okay, so the liquid 1 has color 9, liquid 2 has color 12, liquid 3 color 5, and liquid 4 color 3. Okay, the question here is which liquid has the lowest concentration of hydrogen ions. Now, lowest concentration of hydrogen ions means it should be very basic in nature, and towards this side the basic nature is there. So I can say that liquid 2 is more basic, so that is why it will have the least concentration of H plus ions. So that is your liquid number 2. Next, Lina was advised by her teacher to wear gloves and use forceps while dipping the pH paper in the liquids. What was the reason for this? So that is because of to avoid corrosion, okay, to avoid corrosion from harmful acids. Okay, acids are corrosive in nature, so and bases are also, so if they can touch your fingers directly, it may get corroded. Okay, to prevent that. Next, what should be the color of a pH paper after it is dipped in distilled water? So in distilled water it is neutral, so what should be the color? Color should be 7. Okay, color 7 should be there. Next, which one of the following liquids, liquid 1 or liquid 2? Liquid 1 or liquid 2 will have higher concentration of hydroxyl ions. So now if you see, liquid 2 is more basic because it is towards the basic side, right? More basic, that is why it will have more OH minus ions. Okay. Next, why you can write? Because it is more basic. So next question we have here, Madhav took 10 gram of a green salt powder, okay, in a covered beaker. He heated the beaker for 15 minutes. Madhav noticed that the salt powder turned whitish after 15 minutes. Okay. He also found some droplets on the inner surface of the beaker cover. Now Madhav added a few drops of water to the whitish powder. The powder turned green. What can be concluded about the green salt powder from the Madhav's activity? It contains moisture or not? Yes, definitely it is present in the form of crystallized water, right? Color changes on heating? Yes. Next, What do we call the molecules of water present in the crystals? That is your water of crystallization. Water of crystallization. Next, Madhav repeated the same activity but kept the beaker uncovered. Will the result remain the same? Explain your answer. So if the beaker is uncovered, the droplets of water that was found, right, it will evaporate. You cannot find the droplets of water. So what will be the observation? The observation here will be the salt will become white. Salt becomes white, there is no doubt in that, but no droplets are observed because you have left the container open, so that will evaporate. Okay. Next, what would have happened if Madhav had used copper sulfate powder instead of green salt powder in the same activity? You will observe the same thing. The copper sulfate powder turns from blue to white. Okay, fine. So students, once again I want to remind you about DSET. As I already told you, class 10th is going to be very critical stage for you. You need to take your decisions wisely and with expert advice. So to help you with that, we have DSAT, that is Diksha Scholastic Aptitude Test. So here first of all you have a 60-minute lecture, or you can say a 60-minute lecture is given, concept based lecture, and based on that you write an aptitude test, and then and there it is evaluated, and then you get a one-on-one session with a mentor who can tell you about your strength and your weakness and can tell you the right career for you. Okay, so do not miss this chance. So if you want to join this, so please register for DSAT. Link is given in the description section. Okay. Okay, so this was almost we practice 40-50 questions. So please practice these questions. This is more than enough for your acids, bases and salts chapter. I hope this video was helpful. Stay tuned for the next class.